When you ask ChatGPT a question, it replies in seconds. But inside, something far more complex is happening. It doesn't understand language the way humans do. Instead, it turns your words into numbers. Then it predicts the next piece of text, one small step at a time. So is ChatGPT, just predicting the next word. And nothing more. If that's true, how can something that doesn't truly understand language produce answers that feel intelligent? Let's go inside ChatGPT and see what's really happening. Let's take a simple sentence. My favorite fruit is pineapple. To you, that's natural language. But a neural network cannot process language directly. It operates on numbers. So the first step is called tokenization. The sentence is broken into smaller units called tokens. A token isn't always a full word. It can be a word, part of a word, or even punctuation. For example, my favorite fruit is pineapple might be split into tokens like my favorite fruit is pine apple, and even the period. Notice that pineapple was divided. Modern language models don't memorize every possible word. They reuse smaller subword components. Take running. It might be split into run and ning. The same run appears in run, runner, rerun. With a finite vocabulary of subword units, the model can represent an effectively infinite language. These tokens aren't chosen manually. Algorithms such as byte pair encoding analyze massive text datasets and learn which character sequences appear frequently enough to become tokens. The result is a fixed vocabulary. Now here's something important. The tokenizer doesn't understand meaning. It performs lookup. Each token in the vocabulary has already been assigned a unique numerical ID. The tokenizer simply maps each token to its corresponding integer. After tokenization, your sentence is no longer text. It becomes a sequence of numbers. And that numerical sequence is what enters the neural network. The model never sees words. It only sees integers. But integers alone carry no meaning. They are just positions in a vocabulary. So the next step is crucial. Those integers are converted into vectors. Inside the model, there is a large table. Each row of this table corresponds to a token. When the model sees a token ID, it selects the corresponding row. That row, a list of numbers, is the token's vector. This is called an embedding. At first, embeddings are random. To make these vectors meaningful, the model must be trained. ChatGPT was trained in advance on a very large collection of text like books, articles, web pages, code, even conversations. During training, the model repeatedly tried to predict the next word in a sentence. When it makes mistakes, its internal parameters, including embeddings, are adjusted slightly. Over time, words used in similar contexts move closer together in this high-dimensional space. Consider king and queen. They appear in similar contexts. The king ruled the kingdom. The queen ruled the kingdom. Because their surrounding structure is similar, their vectors become similar, but not identical. King appears more in male contexts, and queen appears more in female contexts. That consistent difference becomes a direction in embedding space. If you take the vector for king, subtract man, and add woman, you land close to queen. No one programmed this equation. It emerged during training from exposure to language patterns. Relationships became geometry. Now these embeddings enter the core of the system, the transformer. The transformer processes all tokens at once. It consists of many stacked layers. Each token updates itself by looking at every other token in the sentence. This mechanism is called attention. Consider this sentence. The animal didn't cross the street because it was tired. What does it refer to? You know it refers to the animal, even though it appears far away from animal. The transformer handles this using attention. When processing it, the model evaluates its relationship with every other token. It assigns higher importance to animal than to street. These importance values are numerical weights computed from similarity between vectors. This is self-attention, and it happens in every layer. With each layer, representations become more context-aware. After many layers, the model builds a rich internal representation of the entire sentence. Not isolated words, but a structured network of relationships. Now comes the key moment. After processing the input, the model predicts the next token. If the sentence is, "The sky is," the model assigns probabilities to possible continuations like blue, clear, or bright. Each candidate receives a probability. The model doesn't know the correct answer. It calculates what is statistically most likely based on patterns learned during training. That's the core idea. ChatGPT is a next token prediction system. Once a token is chosen, say blue, it is added back to the input. Now the sentence becomes, "The sky is blue." And the entire process runs again. Tokenize, embed, process through transformer layers, predict the next token. This loop continues until a full response is generated. That's how paragraphs are created, one token at a time. You might wonder, if it's just predicting the next token, why does it feel intelligent? Because intelligence can emerge from large-scale pattern recognition. The model has learned how humans write, explain, reason, and respond across billions of examples. So when it predicts the next token, it is modeling patterns of human language. It doesn't understand meaning the way humans do, but it captures structure so well that the output feels meaningful. Originally, the model is trained for one task only: predict the next token. That's it. It doesn't automatically know it's supposed to be helpful. So after the main training phase, the model goes through an additional step called instruction tuning. In this stage, humans interact with the model. They ask questions. They request explanations. They compare different answers. Then they rank which responses are clearer, more accurate, and more helpful. The model learns from these rankings. Its internal parameters are adjusted so that answers humans prefer become more likely in the future. This is what transforms a general language predictor into a conversational assistant. So when you type a question, the model isn't just continuing text. It has been specifically trained to recognize instructions and respond in a helpful way. It's still next token prediction, but now it's guided by human feedback. So what looks like intelligence is, at its core, mathematics operating at scale. And now, you know what's really happening behind the screen. So to recap, your text becomes tokens. Tokens become embeddings. Embeddings pass through transformer layers using attention. The model predicts the next token, and the process repeats. That's how ChatGPT works. But what happens when the model needs information it wasn't trained on? What if the answer depends on new data or private documents? That's where retrieval augmented generation, or RAG, comes in. In the next video, we'll explore how models can search external knowledge before generating answers. Because once you understand RAG, you understand how AI systems move beyond static memory and begin using information dynamically. If you found this video helpful, don't forget to like, subscribe, and comment below with the topic you'd like to explore next.